In this video, we will learn how to write an assembly language program to find the largest number from an array. So this program is written for the 8-bit number. And here you can check that in this program, the first line of our code is dot model small. So small indicates that our all data and our all code are stored within only one program segment. And here in this data segment, we have declared these two variables as array and large number. So array variable can be declared as a DB, that is defined byte, and we have declared here 5 8-bit numbers. So the first number is 03H, then 05H, 02H, 08H, and 07H. And this will be stored into the consecutive memory location from this 10001 location to till 1006 location. So the starting location of this array is 10001. So here we are storing that is 03, then next one is 05, then 002, then 08 and 07. So all these numbers are stored in our consecutive memory location. Now the next part is large number DB0. So this number is declared as a 0, and whenever we are storing our largest number, whenever we are finding our largest number, that time we will update it with their large number from that array. So now we have completed with the declaration part of our variables. So in that data segment, we have declared these two numbers, that is array, and the second one is large number. And these numbers are stored in that particular memory location. That memory location we can access later in this program. So now we will go to the dot code segment, that is code segment, and here we are writing the actual code of our program. So this first two lines indicates that we will initializing this data segment in our code segment. So whenever we are writing this move ax comma @data and move ds comma ax, that time we are assigning the values of this physical segment to our logical segment, that is data segment. Now the next part is move cl comma 05 in our array, which consists of total 5 elements, so that we have to assign the values of counter to our 05. So after writing this move cl comma 05, the value of our cl register becomes 05. So here you can update the value of counter, that is cl is equal to 05 in our register architecture. Now the next part is we are writing here move si comma offset and array. So here the values of our SI register we can consider, we are writing here SI, and we will update this value in this segment. So what do you mean by this offset directive? This directive is used to store the starting location address of our array element. And here the starting locations of our array element is 100001. So here this address is 1001, and that will be stored into our SI register. So our SI register will point to the first location of that array element, and this will be updated whenever we have to point to the next element, and this will be pointed to the 10002. But later on we will see how this will be pointed to the next element. But before that, you can check here the current value of our SI is 1001. Now, what is the next statement? We have to copy this value of SI is equal to, first of all, we can write here 1001. Then now we have to copy this value of SI into our AL register. So we are writing here in bracket SI. So whenever we are writing the concept in bracket, that time we are considering here the offset address and effective address of that their particular element. So I'm writing here in bracket 1001. So in that 1001 location, on that memory location, the value is stored, that is 03. So we are putting here move al comma 03. So whenever I am writing this move al comma 03, then our al is equal to 03. So see, in this array register, we are writing here the value that is 0, 3. Now what is the next statement? We have to update the decrement CL. So whenever I am writing here decrement CL, then our counter value will be decremented and it will become 0, 4. So previously it is 0, 5, and once we are executing this statement, that is decrement CL, the CL value will be decremented by 1. So CL minus 1 is equal to 0, 4. So this value is now updated and it will become 0, 4. Here we have written this up label, and this up label will be executed depending on that loop instruction. So once the condition will be true, that is Cx is equal to Cx minus 1, and if Cx is not equal to 0, then our control will be redirected to the label up. But if it is not true, then it will be directly redirected to the next part of our code. Now we will see how this will be executed. So first of all, we have to increment our SI register. So now our SI value will be 1001, and after updation, after incrementation, it will become 1002. So what we have to check here, we have to compare this AL comma SI. So whenever I am writing this compare AL comma SI, that time we can consider compare AL comma in bracket SI. So now check what is the value of our AL register, that is 03, and now you have updated here the value of our SI register. So our SI register will be 1002. Now you can put this value that is given in that compare instruction, and our compare instruction will be compare 03, comma, and on that 1002 location, your value will be stored as a 05. So your value is 05. Now you have to compare this value, that is 03 and 05. So whenever you are comparing this value, this will be your destination and this is your source. So here source is greater than your destination, and whenever your source is greater than your destination, then your carry flag will be set to 1, then your 0 flag will be set to 0, and your sign flag will be set to 1. So after compare instruction, what is the next instruction? That is JNC and next label. So what we can do in that JNC instruction? In that JNC instruction, that is called as jump if no carry. And when it is executed, when our carry flag will be set to 0, then we are redirecting to the particular label, and here we are written this label, that is next label. So in this example, first of all we have to check whether the carry flag will be 0 or not. If it is not 0, then we will move to the next part of our code, but if it is a 0, then we have to go with that next label. So see here in that example we have checked 03 and 05, and after checking this, comparing these two number, our destination is less than source, and that time we have setting this carry flag value is equal to 1. So we are not moving to the next label, we are moving to the next instruction, and our next instruction will be move AL comma SI. So check here how this instruction will be executed. So here you can consider the value of our SI, that is 1002. Currently we are pointing to the second element, that is 0005, and that value will be copied into our AL register. So our AL will be updated and it will become 0005. So now what is the next instruction? That is the next label. So whenever this instruction will be executed successfully, our control is automatically redirect to the next label. And I'm writing here loop up instruction. So what this loop up instruction can do? In that loop up instruction, we are decrementing our counter is equal to counter minus 1. And we have to check the second condition. If our counter is not equal to 0, then we will redirect to the up label. So these two conditions we have to check each time whenever we are executing this loop instruction. So in this example, our counter value is currently 4. So after decrementation, it will become 0, 3. So now the current value of our counter is 0, 3. And whenever we are going with that, this second condition, we have to check the 3 is not equal to 0. And 3 is not equal to 0, the condition will be true. And we will again redirect to the up label. And in that up label, again we have to increment this SI. So now previously our value of SI will be 10002. And now after updation, it will become 1003. Now we are pointing to the third element of our array. So again we have to compare this AL comma SI. So how we are comparing this? First of all, we are writing here compare AL comma SI. So what is the value of our AL? Our AL consists of 0, 5. So now we are putting here compare 0, 5 comma our SI location, and our SI location is 1003. And we are writing here compare 0, 5 comma 0, 2. And whenever I am comparing these two elements, that time our 0, 5 is our destination and our 0, 2 is our source. And whenever we are comparing these two elements, that time we have to check the condition. And here the destination is greater than source. And whenever our destination is greater than source, that time we are setting this carry flag value is equal to 0. Then our sign flag will be 0 and our 0 flag will be set to 1. Sorry, 0 flag is also set to 0. Whenever destination is greater than source, then all flags will be set to 0. So whenever we are comparing this 0, 3 with 0, 5, then our largest number will be 0, 5. Now we have to check with 0, 5 and 0, 2. So largest number from this 0, 5 and 0, 2 will be 0, 5. So what is the logic behind that writing this JNC instruction? And after comparing these two number, that is compare AL comma SI, we have compared this 0, 5 and 0, 2. So this is a kind of pass that we have uses in that data structure. First of all, we are comparing this 0, 3 and 0, 5, and out of that we are finding the largest number, and whatever the largest number is, that we have copied it into the AL register. Now we are comparing this AL with our next SI location, that is 0, 5 will be checked with that 1003 location, and on that 1003 the value is 0, 2. So here out of that two values, our 0, 5 is again largest number. So here we have to check this carry flag. And if jump not carry, then we will go to the next label. So now we are not copying this contents of SI into the AL location. So why we are not copying this contents of SI into the AL location? After using this instruction, here you can check that in that program, in that instruction, that is JNC next instruction, here we have set our carry flag is equal to 0. Now we will directly move to the next part of our code, that is we are jumping to the next label because our value of our carry flag is equal to 0. So in that next label, we have written this instruction, that is loop up. And with the help of this loop up, we are decrementing our counter by 1. So previously it is 0, 3, and after decrementation, it will become 0, 2. So we are writing here counter value is equal to 0, 2. So I'm writing CL is equal to 0, 2. So after decrementation of our counter, in the loop up instruction, we have to check if counter is not equal to 0. So currently our counter value is equal to 2, and 2 not equal to 0, the condition is true, and then we are redirecting to the again up label. So in that up label, again we have to increment the value of our SI. So previously the value of our SI is 1003. So after incrementation, it will become 1004. So now I'm writing here value of SI is equal to 1004. So currently we have updated the value of our increment SI. So now you can check here what is the next line of our code. So in that next part of our code, that is given compare instruction. And in that compare instruction, we are writing compare AL comma SI. So write down here compare AL comma SI. And you have to check what is the contents of our AL and what is the content of our SI. So check here, this is in the register structure. Your value of AL is 05. So you can write here 05, comma, in bracket 1004. And in that 1004 location, our value will be 08. So you can write here compare 05, comma 08. So now what you have to do, you have to compare this 05 and 08. So what is the logic behind in that program? Whenever we are comparing these two numbers, that time what is the largest number will be, that we have to copy it into the AL register. So you have to keep in remember, first of all, we are checking this 05 and 08, and whatever the largest number will be, that we can copy it into the AL register. So previously, whenever we are comparing this 03 and 05, then the contents of AL will be 05. Whenever we are comparing this 05 and 02, then the largest number is 05. Then again we are sharing this value 05 in our AL register. And now the 05 and 08 will be compared and the contents of AL will be updated with the largest number, that is 08. So check here, whenever we are comparing these two elements, our destination is less than our source, and our destination is less than our source. That time we are setting our carry flag is equal to 1, then our 0 flag is equal to 0, and our sign flag is equal to 1. Here we have set our carry flag is equal to 1. And we have to check here this JNC and next label. So in this JNC instruction, we will move to the next label whenever our carry flag will be set to 0. But here our carry flag will be set to 1. So now we are not moving to the next label. We are moving to the next instruction, that is move AL comma SI. So that now you can understand why we have written this statement, because whenever we are comparing this element, that time we have to check what is the largest number out of that two number. And once we got the largest number, so that largest number we are storing in our AL register. So now whenever I am writing this statement, that is move AL comma SI, so we have to check what is the current value of our SI. So now currently we are pointing to the SI location, that is 1004, and in that 1004 location our value is 08. So I am writing here move AL comma 08. So now our AL value will be updated and that will become 08. So now I am updating this value in our register structure, and this will be updated with 08. Now you can proceed with that next part of our code. So currently we got the value of our AL, and automatically we will jump to the next label. And in that next label, again we have to use that loop up instruction for decrementing our counter value by 1, and we have to check the counter is not equal to 0. So check here, our counter is previously 02, and after decrementation, it will become 01. So now currently my counter value is equal to 01. And I'm checking here if it is not equal to 0. So 1 is not equal to 0. This condition is true. And I'm going to the again up label. Because why I'm moving to the up label? Because we have to compare this 08 with 07. Our last element is again pending. So we are moving to the up label and we are executing this line of code again. So what is the next instruction? That is increment SI. So we are writing here SI is equal to, check here previously on that location 1005 and after incrementation it will become 1005. So now my SI will be updated here and I'm writing here 1005. Now what is the next part of our code? So in that next part that is given after incrementation of our SI, we are comparing this AL comma SI. So I'm writing here compare AL comma in bracket SI. So first of all, I have to take the value of our AL and our AL is equal to 08 and my SI will be 1005 and on that 10005 location, my value is 07. So I'm comparing this 08 with that is 07. So I'm comparing with that 08 with 07. That time this value of our destination is 08 and value of our source is 07. So our destination is greater than source and we are setting this carry flag is equal to 0. Then our sign flag is equal to 0 and our 0 flag is equal to also 0. So we are setting all this flag is equal to 0. Now what we have to do, we have to check this carry flag. So our carry flag is set to 0. So what is the next instruction? JNC next label. So here we are checking if our carry flag is equal to 0, then we will directly move to the next label. Now here in this case, we are not moving the contents of SI into our AL register because from that 08 and 07, our largest number is 08. So we are not updating here the values of our AL register with our 07. We are only keeping the values of our largest number is equal to 08 because from out of this all number our 08 is the largest number. So here in this case we don't have to update this 08 with 07. That's why we are directly moving to the next label. And in that next label, we are writing this loop of instruction. So again, in that loop of instruction, we are decrementing this counter value by 1. And here you can check the counter value is equal to previously 01. So after decrementation, it will become 00. So I'm writing here counter is equal to 00. And in that loop instruction, we are checking if counter is not equal to 0, then we are going to the up label. But here 0 is not equal to 0. This condition is not satisfied. So we are not moving to that up label again. And here you can check in this program, this up label will be executed till this loop instruction will be satisfied. But here this instruction is not satisfied. So we are jumping to the next instruction and here whatever the value will be set into the AL register that will be copied into the large number. So our large number will be whatever the contents are previously there in our AL register that will be updated. So our AL consists of 08 and our large number is also updated with our new value that is 08. So in that memory location previously we have stored this 00. So now this 00 will be updated, that is large number will be updated with our new value that is 08. So currently we have calculated the largest number from that array. Now whatever the value we got in our large number that we have to print on our console. So how this value will be printed on our console? In our register structure, the AL value is 08. So whenever we have to print a value on our console, that time we have to add the 30 and we have to set the hexadecimal value of that number. So after adding the 30, we will get the value 38. So that's why we have to write the statement that is add AL comma 38. And now whatever the contents are there in that AL register that we have to copy into our DL register. Because with the help of 02H interrupt, that is DOS interrupt, we are printing the data on our console. So with the help of 0 to H interrupt, we are printing the register value on our console. So this value will be printed on our console by writing this two statement move H, 0 to H. Here we are calling that DOS interrupt and that we are passing to the AH register, and with the help of integer 21H, the value will be displayed on our screen. So now we will see how this program will be executed on our emulator screen. But before that, you can check this move H, 4ch and integer 21H. These lines are written for terminating our program, and our program will be terminated with the help of this DOS interrupt, that is 4ch. The end will be used for closing our programming all statement, and this end is will be used for closing our all data segment, code segment and the stack segment. So in this video we have learned how to write an assembly language program to find the largest number from an array. So now we will check how this program will be executed on our emulator screen. So now let's redirect to the emulator screen. The output on our emulator screen, I have provided the next video. The link is pasted in the description box.